The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the Sizing of Pneumatic Actuator for Process Valve Masterclass organized by Festo Middle East and Northeast Africa. This is Nizar speaking from Festo office in Amman. In today's session, we will highlight the fundamentals how to select the correct actuator for your process valve. This masterclass will be part of masterclasses series planned for this year. I would like to invite you to stay tuned with us and join us in our next masterclasses. These masterclasses are aimed to spread the knowledge and to share with you our knowledge in the selection and the specifications of the process valves, actuators, and automation level in general. So I invite you to join us in next master classes. So please stay tuned and join our next master classes. Before we start, please make sure to adjust your audio settings as shown in the box. If you have any question, please drop your question in the question box as shown in the over here in the screen, and we will be answering those questions during the session or after the session. In our agenda today, for today's session, we will be covering the following topics: actuator characteristics, torques and forces calculation for our application, moving on to the ISO standards for the mounting interfaces, and again going to the let's say air quality requirements to protect our installation, and how to control our actuation speed for opening and closing. Last but not least, what are the tools from Festo which supports you or support us in sizing and selecting the right actuator for your process valve. Before we start, we have to know why the correct sizing is very important to us. Why we need to understand more about correct sizing. Starting with the cost reduction, in case we are selecting the right actuator size for our process valve. In this case, we are saving, let's say we are investing less to select the right actuator for our process valve, to improve our process reliability. To have reliable process, we consider all important factors in our selection, such as safety factors, torques, air quality requirements. Also, when it comes to the flexibility, when we are selecting the correct sizing for our actuator, we are offering great flexibility in our installation with different process valves and control elements. Also, when it comes to the interfaces, the ISO standards, we are having standardization in our plant with the common available standard interfaces. Also, when it comes to the spare parts, we are improving our spare parts management. Less spare parts are required because we are in the correct sizing, and we are operating our actuators under the right operating conditions. So in this case, we need less spare parts in our warehouses. Let's start with the actuator characteristics and how we see the actuator torques, curves, forces for, let's say, to select our actuator for our process valves. We start with the torque curves of the process valves to understand the behavior of the torque requirements. So in this case, starting with, for example, for the ball valves, as we see the torque curve for the ball valves, from 0 to 90 degrees movement. As we can see, the torque is concaved so far, and why it's concaved, not constant, because the ball, it's in direct contact with the seal all the way around, let's say from 0 to 90 degree movement. Moving on to the butterfly valve curves, as we can see, we starting with higher torques, and because of the seal is in direct contact with the disc. But after we move on from the 0 degree towards the 90 degree, no longer the seal is in direct contact with the disc of the butterfly valve. So we see decrease in the torque requirement. Again, we have slight increase at the 90 degree for the torque requirements of the butterfly valve. Last, for the knife gates, penstocks, and gate valves, now we are talking about forces, not torques. And the process valve requires constant force, as we can see in the graph below. This leads us to understand more about the torque charts, torque and forces for the actuator to fulfill these torque requirements. So going into the torque charts for the actuators, starting with the rotary movement, there is two different types of actuators. There is the rack and pinion design, which gives us constant torque no matter of the angle, as we can see in the graph below. This type of actuator can be used with both ball valves and butterfly valves. Moving on to the next type of actuators. As we can see, we have the Scotch yoke design, which gives us higher torques at zero angle, and we have a slight drop in the torque at 45 degrees angle. Then again, the torque increases up to, let's say, towards the 90-degree angle. And also this type of actuators are suitable for rotary movement. It's preferable for the butterfly valve due to the good match in the torque curves. But from the internal design, as we can see, for the Scotch yoke actuators, it's more complicated. We have many parts inside, machined part as well. So normally in the markets or in the design, everybody is using the rack and pinion. Let's say it's more popular to be used because it's more cost effective rather than the Scotch yoke actuators. Last, in the linear actuators, as we can see, forces are constant. In the blue line, we see the extending force for the linear actuator, and in the dotted line, we see the retracting force. Here, to highlight a very important point in the design, if we are designing, let's say, a knife gate valve, we always consider the retract force to ensure that the process valve are able to move in both direction, whether it's extend or retract. Why there is a variation between the extend and retract forces? Because we have difference in area, which is, let's say, subjected to the pressure from both sides. If you see the extend area is much higher or higher than the retract area where we apply the pressure. In our designs, we consider those factors, but so far now I see the torque curves for the actuators and torque curves for the butterfly valve or the process valves. Now, if we look to those charts or graphs, we use those graphs for both process valves and the actuator to show the relation between or the relation between the selecting the right actuator for the right process valve. In this graph, we see the torque curves of the ball valve, also including the safety factor of the, let's say, the torque requirements. This safety factor, we will come to know what are the recommendation of these safety factors and what we can, let's say, take in our consideration those safety factors. Moving on to the torque curves of the actuator. In this case, we have the rack and pinion actuator. On the other chart, we have the butterfly valve torque curve, including also the safety factor. Also, as well, we have the Scotch yoke actuator. On the other hand, we see also the graph of the linear knife gate valves. As we can see, this is the requirement of the force requirement for the angle seat valve, knife gate valve. And also we see the forces which I'm able to collect from the linear actuator, whether it's extend or retract force. After we are done with the torque curves, now let's see how to calculate the torques and forces for both valves and actuators. Starting with the flange pressure rating, it doesn't affect my sizing of the actuator, but normally when it comes to select the process valve, it's the first thing to look at is the flange pressure rating. Starting with the process valve torques, As we can see from this table, there is a different torque related to different desk pressures. This is a very important point when we do the sizing. If we look to the, for example, 16 bar, we have different torque requirements rather than the 2.5 bar desk pressure. So these are important factors to look into while doing the sizing of the actuator. So we have to be aware of these torque differences between the, let's say, nominal pressure of the disc. Second thing we have to look at is the safety factor. This safety factor actually it varies from valve manufacturers. It's recommended from every valve manufacturer to have a reserve torque in case we are using normally in process automation we're using media. We are controlling the media, and there is a variation in the temperature, the pressure, the media property. So it changed the, let's say, the torque requirements. Therefore, the safety factor, we have to consider the safety factor while using or sizing my actuator. Last but not least is the type of actuation. In our case, for the rotary movement, we can select whether it's a double acting or single acting. Then the next step is to know how to select my actuator, whether it's a double acting or single acting. But before we carry on, also to highlight that for the knife gate valves, we are using the same sequence or the same principle of selecting the right actuator, but also to highlight that we should follow the valve manufacturer force requirements and safety factors recommendations. Moving on to one of the examples. For example, here in my list here, or in my example, I'm selecting DN100 butterfly valve with PN10 flange rating and disc pressure of 10 bar. The torque requirements from the valve manufacturer is 41 Newton meter. The safety factor is recommended. What is recommended from the valve manufacturer is 1.35, and the operating pressure is 6 bar. So first thing to consider is the torque, including the safety factor. Because if we design our actuator based on the torque, if we have any variation in the media properties or temperature or pressure, we can't ensure that our actuator can operate the process valve. Therefore, we have to include our safety factor in the torque calculation. If we include the torque calculation, the safety factor in our torque calculation, we see that we need 55.35 Newton meter as a torque to operate this process valve. Also, the second important thing is also to look to the operating pressure of my actuator. As you can see here, the air supply available is 6 bar, so the operating pressure of the actuator is 6 bar. So if we look for the match of, let's say, between the air supply or operating pressure of the actuator and the torque requirements, we look to the perfect match or the good match between the torques and the operating pressure. In this case, we see the 89.9, which is related to size 80, actuator size 80. This is the most important points to look into when selecting a double acting actuator with a butterfly valve or ball valve. Moving on to the, if we are the customer or you're requesting a single acting actuator, we are using this example to just to show you what are the points to, let's say, look into and what are the points to consider in our sizing. For example, also I have a DN100 valve with a flange connection or flange connection PN10 and operating pressure 2.5 bar. The torque requirement from the valve manufacturer is 22 Newton meter, and the safety factor again is 1.35. It's mentioned here, I need a single acting actuator as well. And the air supply or air pressure supply is 6 bar. if we calculate the torque requirement, including the safety factor, we end up with 29.7 Newton meter. So the 29.7 Newton meter is the torque requirements, including the safety factor. So in the single acting actuator, we have to look into 2 points. First point is the spring torque available based on, let's say, the main idea behind using a single acting actuator is the safety. And in case of pressure failure, or if we, let's say, want to stop the signal, then the springs are able to operate the process valve. In this case, we have to make sure our torques, which are coming from the spring, are able to move my process valve. In this case, if we're looking to 29.7, also we see this type of actuator is able to operate based on spring forces. Also, the second topic as well to consider also is my operating pressure 6 bar. If we match with the spring forces, spring torques, and we see also the torques which are coming from the 6 bar. If we are also covering the torque requirements, this will mean to us that we are selecting the right actuator. So in this case, we consider both spring forces and the forces coming from the actuator itself. Last is the knife gate valve. If we see, we are here selecting a DN200 knife gate valve with a line pressure 10 bar. The force requirement from the valve manufacturer is 2,500 Newton. Also, the safety factor recommendation from the valve manufacturer is 1.1 the safety factor. So we are looking also for double acting actuator with operating pressure 6 bar. So if we consider the safety factor, we end up with 2,750 Newton as a force requirement to operate this knife gate valve. So to operate this knife gate valve, we need 2,750 Newton. If we see a data sheet for a linear actuator, as we can see, there is difference between the retracting force and the advancing force. As mentioned earlier, the design will be done based on the retracting force to ensure that my valve is operating whether in forward motion or backward motion, or let's say retracting and advancing. So moving on to the standards on the mounting interfaces and what type of standards we consider in the, let's say, the selection of my actuator for the process valve. We start with the ISO standard 5211, where our actuator meets the process valve. We must ensure the perfect fit between the flange connection and the shaft dimension. Talking about the shaft dimensions, as we can see in this ISO, we have 3 types of or shapes of shafts. We have the double D, we have the round shape, and we have the square shape. Here to highlight also that the square shaft is, let's say, the most common shaft available or used for these process valves. Moving on to the next interface, as we can see, the Namur interface. The Namur interface is where the solenoid valve is mounted directly on the actuator. Here also to highlight that we have three Namur sizes based on this standard. We have the 1/8 inch, we have the 1/4, and the 1/2 inch. To highlight these different sizes, also we have different flow rates. So the most common, let's say, valve or size is the 1/4 inch size. Moving on to the, let's say, the interface where we need to add control element, the VDI, VDE interface, the 3845. By knowing the, let's say, the dimensions of this interface, we have standard brackets to fit in our actuators. So mainly these are the, let's say, the three things to look into while selecting my actuator when it comes to the ISO standards. Now we covered the torques of the valves, actuator and the mounting interfaces, and the torques of the actuators, the valves. So then what about the air quality? In most cases, let's say customers neglecting the air quality that we are using in our system. This is a very important point to look into, because the most common problem, if air is not filtered, we have water content inside the air, which leads to rust, and it will decrease our actuator reliability and lifetime. Particles and oils, which leads to air leakage and energy loss. Why energy loss? Because we are always pumping more air to the system to overcome this air leakage. If we see, for example, our actuator data sheet, if we see here, over here, we see a certain air requirements for this actuator based on ISO standard. What does that mean? 7.4.4. If I'm a customer or I'm looking for a right actuator and I see this number, what does this number mean? If we check the ISO standard, we see the following points related to the numbers. 7, first number 7, which is related to the concentration of the particles in between 5 to 10 milligram per meter cubic. The second number is the 4, is the dew point. This is how water content is measured inside the air. So it's measured by degrees. So we have 3 degrees dew point. The third number is also 4, is the amount of oil content inside the air. So it's also measured by milligram per meter cubic. So this number varies from product to a product. So please always make sure to look onto the operating medium or air requirement for the products to fulfill these needs. We always should consider having the air filtration unit also close to the process valve assembly, As you can see, also many types of air preparation units are available. So please always consider to have those air filtration units close to the process assembly to maintain those conditions and prevent failure and increase your system reliability. How to control my opening and closing speed for the process valve. To control the speed of the opening and closing for our actuator, we can do it whether if it's operating through directly supply, one-way flow control valve, or through the exhaust flow control valve. All we have to do to control the flow, this controlling of the flow, then it's reflected to the speed of opening and closing. Here to highlight as well, in this case, we are able to control different speed for opening and different speeds for closing. If we see on the graph on the right hand, we see the relation between the number of turns and the flow rates for the flow control valves. As we can see here, there is a small screw. By adjusting this screw, the number of turns, then we are automatically adjusting the flow rate, which will be reflected as a speed of opening and closing of the process valve. Moving on, on the sizing tools by Festo. What about if we have tools ready for us, which can support us in the sizing of my actuator without going into the flow charts or torque requirements, force requirements, safety factors, and so on. In this case, we are talking about some tools are available from Festo. We have offline and online tools which help us to select the right actuator for our process valve assembly by selecting for example, starting with the offline tools, simple clicks by selecting the type of the process valve, the torque requirements, and if you need to select one of the valves from our catalog, also it's possible. By selecting also the torque, then you can go to the operating pressure and the safety factor recommended by the valve manufacturer. Automatically, this tool will calculate the requirements, the torque requirements, and will select the right actuator which match the torque requirements of our process valve. This is offline tool. It can be downloaded to your laptops and can be used offline. Moving on to the online tools. Also, we have similar online tools which can be used to select the right actuator by entering the system parameters of my application, the valve and media parameters, the application itself parameters. Then this tool also selecting the right actuator for my process valve. Also, as well, one of the advantages of using this tool, also I'm able to select the solenoid valve and the control elements which are, let's say, mounted on the top of my actuator. For example, limit switch boxes and positioners. So in this case, we have different tools in Festo which can support you in selecting your process valve or actuator for a process valve. After this session, also we will be sharing this presentation with you. Also, as well, we will be sharing with you a guide for you to it's how to go through these online tools and offline tools, and from where we can download our offline tools, and where we can find our online tools in Festo support portal. Now, our session is coming to the end. I would like to invite you also to join to visit our websites, get into the flow, and our Festo website, where you see always new products available there on the website. Also, please let's say, follow us on the LinkedIn page to keep tuned in our next activity. For example, as mentioned earlier, we have master classes series will be planned for this year. Also, on our YouTube channel, you will find the recording of this session on the YouTube channel. And if you have any question, also you can contact us through info_mina@festo.com. I would like to thank you for attending this masterclass. Below are our contact details for me and my colleague, Mr. Christian. Please feel free to contact us if you have any question or if any support is required. Looking forward to meet you again in another master class. So thank you for attending this class and looking forward to see you again. Have a nice day.